Hi, your next challenge is entitled Smaller String Number. You are to create a function that returns the smaller number given two string inputs. Let's see the examples. So they always have two strings here that you're going to receive. You are to return in string form the smaller of the two when interpreted as numbers, as integers. So clearly 21 is less than 44, clearly 1 is less than 1500. They say in the notes section, if both numbers tie, meaning they're equal, return either number. So you get the 5 in this third case. It says numbers will be represented as strings and your output should also be a string. Numbers will be positive, that's an important note. And there's a bonus here. See if you can do this without converting to integers. So we'll do that too. If you want, you can go right for that. I'll probably do the integer way first because it shows a technique that I don't think we've used yet. So I think that might be useful to go through. And then yeah, let's get on with it. So now is your time to pause. You can go for any approach you like to solve this problem. I'm going to start with the conversion to integer method first, then we can use our normal comparison operators to find out which one's lower and then return the corresponding string parameter because they want string form. So to do that, I'm going to say I'm going to convert these int32 class. I can show you this. It's an int32 class with a parse method that takes a string and it converts the string representation of a number to its 32-bit signed integer equivalent. So note that there are some limitations there. 32-bit will get you a pretty large number, but if someone passed a string that exceeded those bounds, you would have problems. And you see that in the exceptions listed below. If you pass null for the string input, you're going to get a argument null exception. If it's not a number, you're probably going to get this format exception. And if it's just too large to be represented by a 32-bit integer, you're going to get this overflow exception. We talked about exceptions in one of the very recent videos, so you can see accordingly how they use the try-catch that we talked about. We didn't show a case. This may be useful, how you have multiple catch statements, right? You can do one for each type of exception so you can respond differently to it, you know. In this case, they simply write bad format. In this case, they simply write overflow, but that's a nice indication like, hey, the value passed in was too big, and then the way you go about fixing these problems is different, and you can get the right sort of information you need to quickly diagnose the problem and correct it. So yeah, that's how try-catch works. We're not going to be this elaborate with it. If you'd like to wrap yours in a try-block, try-catch system, I wholeheartedly support that decision. In 32 parse, I suppose the other thing I should mention about parse is that there's also a try-parse. Try-parse, let's see. You get this return value of whether the operation succeeded, and then you'll notice this extra integer 32 parameter in this out parameter. We will talk about that eventually, but to keep things simple for this video, I'm going to use the regular parse method instead of try parse. But if you want to look at an example of that down here, you see you kind of just declare this number variable, it goes in with the function, and this out parameter kind of makes it a reference where whatever you do inside sort of persists with the parameter. It's like you're referring to the value itself and you're not working just with a copy of its value. But again, we'll talk about that in other videos. These things deserve their own discussion. So we'll keep it simple and just use parse, but I do like to introduce things in little bits so by the time you get to them, it's not completely overwhelming when you go to talk about it. And as always, you're free to do all the reading you want on these pages. So I'll stay with my parse. Int 1 is going to be parse n1. Let's copy this. Make one for int 2. And then we should check, let's see what we needed for this. System namespace. Using system. Okay, so now we have these things in an integer form at this point. We're going to assume that the input they are providing is good, like they said they do. You certainly don't have to if you want to make this problem more realistic. You're welcome to check that input all you like, ensure that it's positive, there's no negative sign, there's no leading zeros on numbers, there are no letters mixed in, you know, you can check all those sorts of things. Once you do have these positive integers, the integer form, let's say if int1 is less than int2, you know to return n1, right? It represents the smaller number. In any other case, you're going to return n2. And that's because if n2 is smaller, then that's what is appropriate to return. And this would also cover the case where int1 is equivalent to int2, and we were told we could return either value, so this keeps things simple. We'll just give n2, they're both the same, it doesn't matter. So I think this gives us what we need. Cool, yeah, there's a way to do it with converting to integers. So I would like to do the bonus challenge as well. See if you can do this without converting to integers. I will refresh. While that's loading, I'm going to use something called the compare method from the string class. And you can read here, it compares two specified string objects and returns an integer that indicates their relative position in the sort order. So if the value is less than 0, it means that string A precedes string B in the sort order. If it's greater than 0, it's the opposite case. String A comes after string B. These are the names they're referring to. And if they happen to be equivalent, you'll get a return value of 0. So that's helpful. Then, go over to the coding. Let's see if I needed anything. Using the system namespace, we'll do that. Okay. Then, now where this thing can get a little bit weird, well here, let's do it this way. Let's write out if string compare gotta refer to the class there. String compare n1, n2 is less than 0, then I know that n1 is a smaller value. N1. Else, I'm going to return n2, very similar to the thing that we did with the integers, but now we're dealing with strings and we're leveraging this compare method to handle that. Just sort of do a lexicographical comparison. There's one catch here where this doesn't quite work, and I'll run it to sort of highlight that. There's a little bit more we have to do to complete the program. That's great, bonus points if you want to pause and think about where this comes up short. But you can think of string compare as sort of doing like a dictionary sorting of strings. So let's see what happens when we run this. Okay, so there were no errors in running the program, but we see we have problems because the test failed. And if you want to see the tests, you can click on that. In particular, we got dinged on this one. It was expecting 16, which is definitely right. 16 is less than 1500. But do you see how, from a dictionary kind of comparison standpoint, if you're just looking at these two numbers, right? You see the 1 and the 1 are equal, that's fine, they're still the same. Then you get to the second digit, or character I should say, and the 5 is less than the 6. So this sort of gets sorted ahead of the 1, 6. And that's not what we want. That doesn't work for the problem at hand here. It works well when the strings are the same size, right? If this had been just 1, 5 and 1, 6, we saw that ours returned the 1500. It would have returned 15, which is indeed less than 16, and we would have been just fine. So I'm going to add a little thing to basically say, with these numbers, right, you essentially know that since they're positive integers, that if one size is bigger than the other, that's the larger number. This one has 4 characters, this one only has 1. So regardless of what the digits are, this one's going to be bigger. That's 4. So I'm going to add something like that, where I say if n1.length, remember it's a character array, so we can have that length, is greater than n2 length. Maybe I should have worded that. Let's do it like this. If n1, we'll try to keep our logic the same. If n1 length is less than n2 length, we have different size strings, return n1. And then we're out of this whole function, we're done. Similarly, if n2 is less than n1.length, return n2. Again, if this hits, we return n2 and we're out. The rest of this logic doesn't even run. And then essentially, once we get to this point, we know that the string lengths are the same size, right? If n1 is not shorter, it's not greater, then they have to be the same length. So this logic should work out in that case. So let's try this. Okay, good. That covered that test case for us. So there you have both an integer solution and one without converting the strings over. The new concept, I suppose, would be this compare method. Feel free to read more about that. The try parse is quite useful too, and if you want to really get ahead, you can look into the out parameter. And there's also an in one and a reference one, but that can be for another day, that's fine. So hit me up with questions as usual, and see you in the next video.